Hey everyone, and welcome to your masterclass on a really crucial topic for your SPM Chemistry exam, transition elements. Now, I know this topic can feel a little tricky, but trust me, by the end of this session, you're going to have all the tools you need to absolutely nail it. Okay, let's get into it. Look, we all know the best way to get ready for a big exam is practice, practice, practice. So I want to let you in on your secret weapon, the MCQ SPM platform. You can jump on the website at mcqspm.com, or, even easier, just scan the QR code on the screen with your phone to grab the app from the Google Play Store. It's packed with past year questions you can get that active practice in. So here's our game plan for today. We just talked about your super tool for practicing. Next up, we're going to properly meet the transition elements. Then, we'll get our hands dirty and crack some real exam questions. After that, we'll luck in their 4 special characteristics, and, finally, see how these elements are absolute powerhouses in the real world. Let's do this. Okay, first things first, before we can even think about tackling exam questions, we need to build a rock-solid foundation. So let's get to know these transition elements. Who are they really? It's actually pretty simple. When you look at the periodic table, the transition elements are that big block of metals sitting right in the middle, smack dab from group 3 all the way over to group 12. You definitely know some of these guys already. They're the heavy hitters like iron, Fe, copper, Cu, and chromium, Cr. All right, foundation set. Now for the really fun part. This is where the rubber meets the road. We're going to take what we know and apply it to some actual SPM past year questions. It's time to start thinking like an examiner. Check this out. This is a real question from a recent paper. It's asking for the special characteristics and gives you 4 options. This format is a classic. You will 100% see questions just like this. So go on, hit pause for a second, and really think about it. Which ones are the right ones? So, how'd you do? Let's break it down. Number 1, forming colored compounds? Yes, absolutely. Number 2, used as a catalyst? You bet. Now you've got to pay close attention to 3 and 4. These are classic exam traps. Examiners love to catch students with these. Transition elements are tough, strong metals, right? So they have high melting points, not low ones. And their other claim to fame is having multiple oxidation numbers, not just one. Remembering these 2 traps will literally save you marks on your exam. Let's try another one. I want you to see the pattern here. This question asks for a special characteristic again, but it's phrased a little differently. It gives you 2 examples, iron and copper, and asks for their defining trait. Can you spot it? And the correct answer is they have more than one oxidation number. See that? It's that same concept from the last question's trap. This idea of having multiple oxidation states is a fundamental superpower of these elements, and it's clearly a favorite thing for examiners to ask about. Okay, now that we've seen how these ideas show up on an actual exam, let's get organized. We're going to do a deep dive into the 4 special characteristics, or as I like to call them, the 4 superpowers of transition elements. Superpower number 1, they are incredible catalysts. So what on earth is a catalyst? Well, think of it like a coach for a chemical reaction. It jumps in, speeds everything up dramatically, gets the reaction to the finish line faster, but, and here's the magic part, it doesn't get used up itself. It's ready to go again for the next reaction. The perfect example of this is the Haber process, which is used to make ammonia for pretty much all the fertilizer in the world. So nitrogen and hydrogen gases go into a reactor, right? But on their own, they're pretty lazy. They need a big push. That push is the iron catalyst. The iron gets in there and helps them combine way more efficiently to make ammonia. Without that iron, the whole process would just be too slow to be useful. All right, on to superpower number 2. This one's a bit more flashy. Unlike a lot of other elements that just make boring white powders or clear liquids, transition elements create this incredible rainbow of vibrant colors. This is exactly why so many gems, like emeralds and rubies, get their brilliant colors. And this table just shows you what I mean. Look at that. Copper 2 gives you that classic bright blue solution. Iron can be either green or brown, depending on its mood. And you can't miss that deep, rich purple of manganate 7. Now, this is important. Memorizing these is a huge advantage, especially for your practical lab exams, because you'll need to identify them by sight. And here it is, superpower number 3, the one we saw trip people up in the exam questions, variable oxidation numbers. All this means is that a single transition element can form different ions that have different positive charges. It's like an actor who can play different roles. 1 minute iron can be the +2 good guy, and in the next reaction, it can switch to being the +3 character, and its properties totally change. Let's stick with iron. It's the perfect example. On the left, you see iron playing the role of the iron 2 ion, or Fe2+. This guy usually forms green compounds. But then, on the right, it's playing the role of the iron 3 ion, Fe3+, which makes those rusty brown compounds. It's the same element, just in 2 different states, giving you totally different colors and properties. Pretty cool, right? Last but not least, superpower number 4. They form complex ions. Now, okay, I know those formulas can look a little intense, but don't panic. The idea is simple. You have a central metal ion, and it acts like a magnet, grabbing onto a bunch of other smaller molecules or ions all around it. This is super important in biology. The iron in your blood's hemoglobin, it's part of a complex ion, and that's how it carries oxygen around your body. So we've gone through the theory, we've looked at the exam questions, but you might be thinking, so what? Why does any of this matter outside the exam hall? Well, it matters because this chemistry literally builds the modern world. Just look at this table. It's like a hall of fame for industrial chemistry. We already talked about iron and the Haber process making ammonia. But then you have platinum, which is essential for making nitric acid, and vanadium 5-oxide, which is the key to making sulfuric acid, one of the most important industrial chemicals on the planet. These elements are the secret engines driving modern industry. And it's not just tucked away in factories. It's all around us, in plain sight. The strong iron and steel that make up our bridges, our cars, our skyscrapers, it's the backbone of our entire infrastructure. These elements are, quite literally, everywhere. So there you have it, a full-on breakdown of transition elements. Your mission now, should you choose to accept it, is to take all of this knowledge and really make it your own. Okay, let's do a quick-fire recap of what you absolutely have to remember. First, the 4 superpowers: catalysts, colors, variable oxidation states, and complex ions. Second, do not fall for those exam traps. They have high melting points and multiple oxidation states. And third, always remember the real-world connection. These elements are essential to our way of life. You know, I can explain this all day, but the truth is, the best way to really learn something is to do it yourself. So now it's your turn. Head over to MCQ SPM, start doing those questions, test yourself, see where you're strong, and lock this knowledge in for good. I'll leave you with this final thought. These elements aren't just a topic in your textbook. They are the fundamental building blocks of the world you see every day. As you continue to study chemistry, think about that. What future will you build with them? Thanks for joining me.